Hello everyone and welcome to this video. So in this video we are going to be getting our data ready. So same step as last time. We're going to be filling in values, which is what we did last time, but today is part 2 where we will be doing this step a bit differently. So in the previous video we learned how to do this with the Pandas library. So today we're going to learn how to do it purely with Scikit-Learn. So let's start now. So here I am at Jupyter Notebook, where this is where we left off last time. Okay, so in the previous video, as I told you, we learned how to convert with Pandas data frames. Okay, so we learned how to fill in missing data with Pandas, and yeah, so we did that using different modules such as the random module. So now we're going to do this with Scikit-Learn. So I'm going to put in my nice title here. So now we're looking at option 2, which is hang on, let me just do something. So now we're looking at option 2, which is, so today we're going to learn how to fill missing values with Scikit-Learn. That is not how you write it. There we go. Sorry guys, inconvenience. There you go. So now that we have written that, so in the previous video we filled in the car sales missing data set. So we cannot really do that with the car sales you used in the previous video. So we have to re-import this. So we're gonna say car sales missing is equal to pd.read CSV. So mine is in the data folder. Car sales missing data.csv. Okay, so we're going to go ahead and say car sales missing.head, and there we go. So this will have some empty NaN values. So we learned about these. So let's check out how many missing values it has. So we're going to say car sales missing dot is NA dot sum. Okay, so now we have 49. So now we have 49 make. So 49 missing values from make, 50 for the rest. So we are going to learn how to fill that in with Scikit-Learn. So the first thing we're going to do is we're going to look at the price column. So we're going to get that out of our way, because when we're going to split our data into X's and Y's, so features and label matrices, price will be a labels matrix. So what we're going to do is we're going to drop all the rows that have missing price values in them. So here I'm going to write drop the rows with no labels. So what I mean by this is price values. Okay, let me just put a space there. There we go. So again, what we're going to do is we're going to say car sales missing dot drop NA. So we can use Pandas for this, because Scikit-Learn doesn't really have anything like for this, as long as I know. So we're going to be using Pandas just for this small step. So subset is basically like which column you want to look at. So we want to look at price column, okay? Because if we didn't put in the subset, then we practically would have lost like 200, and we would have lost 249 rows. Okay, So we don't want that to happen. So it's very important to put this. Otherwise, you'd have to import it all over again, which is boring. So in place is equal to true. So this allows it to stay there permanently. And yeah. So now we're going to just check again if the price has disappeared. So car sales missing dot is NA dot sum. So now there's 0 for price, but then it's sort of gotten left over here. That's because maybe some of the values that were NaN were on the same row as some of the price values, so maybe that's why it happened. But don't worry too much, okay? It's fine. So now what we want to do is we want to split into X and Y so we can start filling in all the values, okay? So we're going to write here, split into X and Y, okay? So I'm going to say X is equal to car sales missing. I need to spell this correctly, don't I? Car sales missing dot drop, because we do not want to include our price column because that's our target column. And then I'm going to say access is equal to 1 because we want to do the price column and not the price row because there is no price row. And then we're going to say Y, which is our labels matrix. So we're going to say car sales missing, and then all we're just going to do is just grab the price column from here. So because price is fine, it has no more NaN values. So what we're going to do is we're going to we are going to want to just work on X now. So we're going to say X dot is an A dot sum. So now that's just going to not include the Y, okay? So now let's go on to the big step, which is converting the values, okay? So I'm going to write fill missing values with Scikit-Learn, okay? So we are going to import a new class, module class, whatever you want to call it, that we have not seen before. So from sklearn dot impute, so imputing or impute is to just fill in missing values. So we discussed that in the previous video where I said that I would mention it in this like sort of section. So from sklearn dot impute import simple imputer, okay? So it's probably quite straightforward what it's going to do because it's a simple imputer. It's going to impute everything simply. So after that, we're going to say sklearn from sklearn.compose import column transformer. Okay, so what this we have we use this column transformer in the part where we learned how to convert categorical values into non-numerical values. So that was the video before last video, okay? So I can put the link to that if you want, so you can watch it, go back and watch it, but yeah, so we use this in that video. So let's just write fill categorical values with a random string and numerical values with the mean. So what I mean by a random string is basically we're going to create a list like we did in a previous video but with pandas instead. And basically we had these 3 lists for the categorical values and we basically picked a random value, okay? So I'm just going to copy all these lists to save time. So I'm just gonna put all my lists up here, I guess. So there's only 3 lists, I guess. It won't take that long. So just slowly, very slowly. I don't know why I'm so slow today. So and then last one's a copy, which is just a bunch of numbers. I don't see why I'm not writing this out, but it's fine. It's what we're doing anyway. So now that we have got all our lists to pick on, that should be fine. So I'm going to create an imputer for all the columns that need imputing. So I'm going to say make imputer is equal to simple imputer. So you need to put in a strategy. So our strategy we're going to use for categorical values is constant. So what we're telling it to do is we're going to tell it to, so whatever NaN value you find in that specific column, I want you to fill it in with a value. And then after we've done the strategy, we want to put in the fill value. So fill value is equal to random.choice. So we imported random in the previous video. So random.choice make. So it just chooses sort of randomly from these lists. Okay? And then we're going to create a color imputer. So this will take quite a while, but it is worth it. So is equal to simple imputer. The strategy is equal to constant. Oh my goodness, what is wrong with my typing today? And then fill value is equal to random.choice, and then we're going to pass in the colors. Now we're going to look at non-numerical values. So that is num imputer, so that's for numbers, is equal to simple imputer strategy is equal to mean. So we don't need to add anything if the strategy is equal to mean. And let me take away that. There we go. And then we're going to do the door imputer. I don't know why I didn't do that before. So we're going to do door imputer is equal to simple imputer. Strategy is equal to constant again. And then we're going to do fill value is equal to random.choice. Random.choice. And my list is called num of doors. So now, after spending a lot of time creating these imputers, we're going to go on to defining which columns we want each imputer to impute. Okay, so we're going to define columns. So this one is a moderately short step, let's say. So I'm gonna just go make feature or make column. I'm just gonna prefer feature. So make feature is equal to the make column in our car cells, and then we've got the color feature, which is equal to the color column, and then we have got our door feature, which is equal to doors, and then last of all we've got our num feature, which is equal to odometer km. Okay. There we go. So now we've done that step. We need to match the columns. So we actually need to sort of create and match the imputer properly. So create the imputer. Okay. So I'm just gonna write here what an imputer is, just so we know. So it is something that fills in missing data. Okay. There we go. So what we need to do is now we're going to put in our column transform into action. So we're going to say imputer is equal to column transformer, and we need to pass in a list of tuples. Okay, so what we're going to do is we're going to say make imputer. So that is the name of our sort of, let's say, imputer. So that's the name, and then you want to put in the actual thing. So make imputer. That's not in a string. And then we're going to put in make feature or whatever column matches. Okay. Okay, and then we're going to continue. So again, another tuple. So then I've got my color imputer, so that's what I want to call it. And then we need to write in color imputer again, because that's the actual thing. And then we need to match it to a column by going color feature. Okay, and then comma. So let's do that again. So we're gonna go door imputer, and then we're gonna go door imputer again. So door imputer, and then we're gonna go, and we're gonna go door feature. And then last one, we're getting close, is the numerical one. So that one is the num imputer, and then we've got to type it in again. So num imputer, and then we're going to go num feature. Whew, so that is quite a lot of work. It does take quite a long time, as you have seen. So now the final step is to transform the data. So most important step of all. So we need to go field x is equal to imputer dot fit transform, and then we're going to pass in our x data. So it would have now turned into field x. So we're going to view field x. So let's see if this works. Oh my goodness, it did. So that actually worked. All of this code worked as we wanted it to. So now we're just going to create a quick data frame just to replicate this x over here, because right now our x is just a numpy array. So we're going to go car sales field is equal to pd.data frame. So we're going to pass in our field x, and then we're going to pass in a list of the sort of column names. So I'm just going to write here columns is equal to, and then we're going to pass in the list. So make color doors, and then last of all is odometer kn. Okay, so we have now done that. Let's now view, let's say car sales, oh god, car sales field dot head. Wow, wonderful. So now that has worked. Let's just check to see if all the values have been filled by saying car sales field dot is an A brackets dot sum. There we go. So that has now worked. So now we're going to just try to convert our data into numbers. So I'm just going to write let's try and convert our data into numbers. Okay, so we're going to go, I think in the previous video, we did this step where we are just converting it into numbers, just to check. So we did it in the previous video as well. So now we can just copy this, and now that should work. And yeah, so that should work now. Okay, that has not worked. What has happened? Input contains NaN. Okay, that's because we put in X here. Instead of putting in X, we need to put in car sales field because it thinks it is our previous X, which is not what we want. Okay, so now that has worked, we are going to do another final step. So now we've got our data into numbers and it is filled. What we're going to do is we're going to fit the model. So let's fit the model. Oh, okay. So oh no, I'm just gonna correct these. There we go. So now what we have to do is we're just going to do the usual thing. So np.random.seed 42, and then we're going to do from Scikit-Learn .ensemble import random forest regressor. And then again, we're going to go from Scikit-Learn .model selection import train test split. Okay, so we're just going to split our data. So we're just going to go X train, X test, and then Y train, Y test is equal to train test split. So we're going to pass in our transformed X. So that's the one that is numerical and is filled in. We're going to pass in the Y, so that does not need to be changed. And then the test size is equal to 0.2. So now we can fit our model. So model is equal to random forest regressor. And then what we're going to do is we're going to say model.fit X train, Y train. And then what we're going to do is we're going to score it. So this is the moment of truth, guys. So model.score, I'm just going to pass in X test and Y test. So that's model.score. So now I'm going to score it. Voila. So we got this quite low score. But then in the video we learned how to convert into non-numerical values, and we tested it. We got a higher score, but You might be thinking, why is that? The data is the same now that we have filter. Well, not exactly the same, but quite closely the same. Well, that is because if we checked the length of our car sales field as well as the length of the original car sales, you would see that there's 50 difference, so 50 rows difference. So that is enough difference to make this score go lower. Okay, so that is why it's like that. So we have now finished the step of getting our data ready. So the next step is to learn how to pick the perfect model for your machine learning, like for creating your model. So how to pick the perfect sort of model to build upon. So we're going to be learning that in the next few videos, probably 3 videos on that. And yeah, so if you like this video, please like and subscribe. That would help a lot. And if you have any doubts, please comment them in the comment section below. I will try my best to answer them. And yeah, I guess that's the end of this video. So bye, and look out for my next video.